So we have a small question. So what on programming languages like C, C++, or maybe basic Java, you have that the previous you have in C, C++, or Java.
Some Java, yeah.
You have Java.
Yes.
What about
There's some experience with C, but I don't have any experience with Java.
what is object-oriented concepts? You are aware of object-oriented concepts?
No.
Okay, fine. Fine. You have knowledge of C.
Yeah.
Fine. So in Java language developed by James Gosling and others in the year 1980s and later renamed to Java and was officially released in the year 1995, May 1995. It's based on C, C++. So anyone who is not having knowledge of can understand and work with Java. So what are the features of Java? It is object-oriented, class interpreted, secure, listed, make, auto-created, various features of Java programming language. One. The first thing it is simple. Is we are saying it is simple. Now, how it is on the syntax of C, C++. Most of the syntax is similar to C++. So just C or can easily understand and work with Java. The variables, the way of difference, doing the functions, the structures. So things are similar to C++. The problem so in the background, in understand and what it is simple. And I think it is object-oriented programming language. When we are talking about C, it is procedural programming. In the task into several subprograms. Into programs. Programming is the task into several objects. The object is nothing but the combination of data and the functions. Taking the task into several objects is known as object-oriented programming and an object-oriented programming language. Now, what is of development using object-oriented programming? So the function development, you can say the systems with object-oriented approach when compared to procedural approach. And in case you want to make any changes in future, also to the changes into the procedure. Object-oriented programming languages. The first object-oriented programming language was similar 60. Small talk in 7% pure object-oriented programming language. Now everything is and all. That's percent pure. C++ oriented programming language. 100% pure. It is just object-oriented programming. Why? We will see. So programs, how in C, write programs in C++, which is oriented programming concepts of. It is oriented language, but it supports both procedural and all. So that's why oriented programming coming up, and it is pure object oriented, but not 100% pure. Now, why not percent means data types are not classes. If everything is classes, then we can say it is a 100% pure object oriented programming language. But data types are not classes. So it's pure. Now, how pure means we can create any program without needing a class. In a class, we can't write a single program in Java. We want to say with Java, we want to display welcome message with class. So without defining a class, we cannot write a single program in Java. Pure means because data types are not classes. That's why it's not 100%, but it is pure. So we are Java. Most important feature of Java is platform independent. So platform, we are referring to the operating system and the underlying hardware. So run anywhere. Just write one and run anywhere. So we can write on one platform and we can run it on any other platform. Any changes to the code. It is also portable but with minor modifications. Have to make changes in the code, but they're portable. But without making any change in the code, you can run on any platform. The feature compiled. C++ are compiled, Java compiled and interpreted. And interpretation. In source code will be into byte. What Java we have? For example, we have some Java which will contain the source code. When in Java compiler, it is code called byte code. It is called byte.class. That will contain the byte code. And what it means? It is intermediate code. It is not a physical machine. It is rated by the compiler for a machine. Virtual machine. Understandable by virtual machine. A virtual machine, it is not a physical machine. It is a program. So, Java generates intermediate code called bytecode, which can be later converted into the actual machine code during execution time. So generate the code for the particular machine code. You not consider on which platform compiling the bytecode, which can be converted into the machine code. So because it's just platform independent. So we can on one platform and we can take that .class file and we can run it on another platform. So we will have a compiler, generate the bytecode, the intermediate code for bytecode, and who will end that bytecode means JVM. So the compiler is generating some code which is understandable by JVM. And what is the JVM? It is a Java virtual machine. It is a software which will understand that bytecode and it will convert that bytecode into the actual machine code and will have its own JVM. Windows, say Microsoft JVM. Linux JVM. Solaris will have its own JVM. Macintosh will have its own JVM. So every platform will have its own JVM. Microsoft JVM we cannot use in Macintosh. But Java is platform independent. So what the compiler is generating, convert that into the actual machine. We will understand the bytecode and will convert that into the actual machine. So that's two-phase compilation and interpretation. Then it is actually going into the actual machine. So we can run one machine and run on any machine. So that's why it runs and run anywhere. Code which is understandable by JVM. Every platform will have its own JVM. What the JVM will do, the JVM will convert that bytecode into the actual machine. So right way or compiled and interpreted, Latin, what all we discussing. So it's robust. So memory done implicitly by Java, that is auto garbage collection. You have to do it explicitly in Java. It is Java take care of memory implicitly. And build exception handling mechanism. It's nothing but like runtime error. So exception handling mechanism. Fixed data size across all the platforms. Features platform will change. Platform, for example, integer is occupying 2. Same. Some other platform it may occupy 4. That increase size of operator to check how many bytes are allocated. Then requirement we may increase or decrease. But we maintain fixed data access across all the platforms. Indeed, 4 bytes means it is 4 bytes everywhere. An application which performs more than one task simultaneously. Word document. later Word document. Now, when 12 words, 100. When we are typing, suppose I am typing E4 space. Immediately it has counted that word, okay, 113 words, and it was also checking for the spelling mistake. One thing is the spelling mistake, and another one is it is also counting the word. First of all, it is allowing us to enter the data into the document, and the data it is checking for the spelling mistake, and so it is counting. So things are happening simultaneously, and all these things are happening within the same application, single application. These are called multi-threaded applications. Where when we are playing the game, so we are playing as in, so we display the time left and it music in the background. To play the game, as we are playing the game, some music is played in the background. Time left one process, play one task. Okay. So multiple things happen within a single application. So such are called multi-threaded applications, and Java to develop such type of applications. So Java multi-threaded, that is one feature of the multi-threaded language. So allows to develop web-based applications and secure. So does unauthorized program or ITS program to interact with our application. So second level Java. Any authorized program or a virus program to interact with our application which is developed secure. Now we have discussed that it is going to, the compiler is going to convert, is going to some code called bytecode will be converted into the actual machine. That application, that code is bytecode or not. Bytecode specification. It will allow to process, otherwise not. So secure. This stuff which run on different machines in the network or internet. So to develop distributed application. Now distributed application is running on my in the internet. Some application may be running in the server, the application may be running in the client. The whole one located across multiple locations, office and branch offices. So he is using some software which is in their main office and in the branch office. So they have to something, okay, but the day, so they have to update something to the main part of the application will be running in the main branch, some X location, and the branches are there across and different. So the organization, they are having one software which is running in different. So distribution or a simple, like when you say money from an ATM center, let's say when ATM center, some software is running in the ATM center which is allowing us to enter details. That particular machine, actually it is available somewhere in our branch, which we have our account, the branch there. So what details we are giving, so it will check whether that PIN number or whatever details we are entering valid or not. and withdraw that much amount for that particular day. So, it will allow us to is running in that ATM. Where the software is running in the somewhere else in the server. The bank. We know so wherever we are, we can withdraw the money. Condition. So classes as and when required at runtime. So as and when required at runtime. Of Java programming language. Any questions after this?
I don't have any.
Okay.
I know, like, the beginning, so I was saying, if you have a session going on, I know Adnan is on one session, and he was telling I just started a couple of days ago, so you can probably catch up with that. Yeah.
Okay, Kava is available in 3 flavors. Standard for developing workstation applications, desktop applications, entering complex outside business applications. Large, when we are saying enterprise applications, so large scale applications. And micro applications which run in the mobile devices like cell phones. With Java programming language using which we will program. We have a development kit which will allow us, which provides various tools to compile Java program. Because like Java C, Java compiler is one tool to compile the Java program. One interpreter, one tool to run the program. So Java development kit to provide various tools and run application. We have Java environment which provides variety classes and the runtime environment. We can create our own application. When we require something which is already and all, we'll be developing our application. In Java virtual machine which converts the bytecode into the native machine. And the relationship between JDK, JR and JVM is nothing but JRE plus tools. JRE and other tools. Tools like Java C, the Java compiler, Java interpreter, like that. Many tools we have. JRE and the JVM. JVM, so we have different components in the JVM. Which is responsible for loading the bytecode. Verifier or bytecode verifier is the internal structure of each and every class loaded. Java is secure. So not allow any unauthorized program or virus program to interact. This will be done. Whatever bytecode is loaded, whether valid Java bytecode according to the specification or not. it will to process. Otherwise, stop there. It will not virus program to try to do the bytecode into the actual machine. Just-in-time compiler, which is to improve the execution speed of a program. So, of repetitive nature and interprets the code. Because it will be built compilation. Because we run it, it will convert and execute and will not be maintained anywhere. We are talking about interpreter. So will not maintain the converted code anywhere. But when compiler does that. Like now also. C file, the source file, which is the source code. A backup file. Dot object machine code. C, the executable file. So the machine code, converted code. Same way here in Java, dot class file, just now we have seen. One file will generate, will contain the bytecode. So the company will maintain the converted code, but does not maintain the converted code. Every time it will return an execute. The execution speed of the Java program. They have done to match the execution speed with the so they have more component to the JVM. It is a software program. So they have component. So that's the JVM. So the compiler in the code which is of repetitive nature. Means for example we have some for loop which is 10 times. And if we have 5 statements. So 5 is 50 lines of code. Interpreter 50 conversions and executions will take place. In this compiler, that 10, that whatever we have, once executed 10 times. So executing every time, convert once and execute many times. That will improve the execution speed. Program. Components of the JVM. So when we compile that using the Java compiler, it generates the bytecode class file. The class loader will load that bytecode maybe from the local disk or maybe from the network disk. If it is whatever. Then give it to the verifier. The class verifier will check for the internal structure of each and every class loaded according to the standard Java code specification or not. If it is according to the, then give it to the execution engine by actual machine without. So these are class file verifier execution. And in C, C++ and Java, Java explicit pointers. Because just now security or secure. So again, this is security purpose. Can get access to the locations. And if are not handled properly, it may lead to some issue. So we for us to define a pointer and work with. So no error overloading. Is nothing but additional definition to an operator. An operator can perform one task, one operation. Suppose we are asking it to perform more than one operation. can C++, but not in Java. No lens on classes. A class and one base class. Other concept for this is global variables and standalone functions. We cannot write outside the class. Everything must be part of the class, including the main. Anyways. That's why it is pure object-oriented programming language. Without we cannot define anything. With class is the concept program. So in C++, we use header files, hash include, string.h, math.h, like this. Header files concept, we have something called packages. We have this concept. So we will put all the related classes and interfaces. And import and use. This is between C, C++ and Java. That is introduction to Java, the features, the R, the flares, JVM, the components of JVM, and between C, C++ and Java. So we have covered today. As for that table. If you have any questions, you can ask.
Like, I don't have any questions till now. It's okay. I got it. What all you said.
Okay. Fine. Okay, for today we'll stop here. We'll conclude our session here. Everything will continue in the next session. You ask something.
I just wanted to ask, if you started that previous session a couple of days ago, if you could just send me the note from them, and then I can catch up to that and join you in that session.
To join with Adnan batch.
Yeah.
Okay. One of the classes that batch. All with core Java, right?
The beginning, data types, object-oriented, programming concepts, and things like that. So, core I'm okay with, but I just want to, to get it.
Yeah. So then you can run in this batch only. Why? Because that's already a mix of core Java covered.
All right, that's good. I don't mind. That's good. Yeah.
Yeah.
Yeah. Good.
Anyone else related to the training?
No, thank you.
Okay. So we will discuss in the session. So after the session, we'll be sharing the notes, demos, like whatever we've done. So all documents I'll be sharing after the session. Okay.
Okay.
We'll connect.